Hello friends, in the previous lecture we have seen that examples on that your associative law, commutative law, also De Morgan's law. How to prove that De Morgan's law, associative law and absorption law by using truth table. In the today's lecture we have to do the same examples on the truth table. So let us write down question. Construct truth table for following. Construct truth table for following statements. Construct truth table for following statements. And first one, your first proposition become that is P or negation of P and Q. What is your first proposition? That is P or negation of P and Q. Second proposition is P or Q, we can take small q, P or Q, or with, second one is P or Q, or with negation R, and third statement become, statement or third proposition become, that is negation of P or negation Q, right? Negation of P or with negation Q. Okay. So this is third one. So your third proposition become negation of inside bracket P or negation Q. So you have to construct the truth table for the following three statement or three proposition. So we have to do the one by one simultaneously. Let us write down the solution for your first statement, that is P or negation inside bracket P and Q. So in that your first statement, how many proposition? There are P and Q, there are two proposition. In that your truth table, that is 2 raised to 2, that is 4 rows. Okay. So make the table for first one. So first column for proposition P, second column for your proposition Q, next third column for your proposition P and Q, next fourth column for your negation of P and Q, and your last column for your P or negation of P and Q, right? This is your truth table. Truth table containing 4 rows and 5 columns. Okay. So this truth table containing 4 rows and your 5 columns. Okay. This is truth table containing 4 rows and 5 columns. Okay. So your first column for proposition P, there are 2 T values. There are 2 T values and 2 F values. F means false, T means true. For proposition Q, take the alternate value T F. Next column for your proposition P and Q. In that your conjunction, if both values are T, the result value become T. So both values are T, result value become T. And in the remaining cases, its value become F. In the remaining cases, its value become F. Next column for your negation of P and Q. We will take the negation of that column. So negation of P become F and negation of F become T. Right? Next, your last column for P or negation of that P and Q. Okay? That means we have to take or between first and fourth column, right? Or between first and fourth column, or means in disjunction. In that your disjunction, if both values are F, right? If both values are F, the result value become F. If both values are F, the result value become F. And in the remaining cases, its value become T. So there is both F, no, the result value become T. There is both F, no, the result value become T. There is both F, no. There is both F, no. So result value become T. So in your last column, containing all values are T. So then given statement is your tautology, right? Second one. What is the second one? That is P or Q. Again inside bracket complete or with negation R. That means there are three provisions P, Q, R. That means there is 2 raised to 3. That is 8 rows. Okay. So that on the table, construct the table. First column for P, second column for Q, third column for your provision R, next column for your negation R, next column for P or Q, right? Next column for P or Q, again or with negation R. Okay. So this is truth table containing 8 rows and 6 columns, right? This is your truth table containing 8 rows and 6 columns. It is so easy. We have to only the reverse only that column truth table for your conjunction disjunction. So this is 1, 2, 3, 4, 5, 6. Again 7, and this is your last 8 rows. There are 8 rows and 6 columns. Okay. So your first column for your provision P. In your provision P, there are 8 rows. That means we have to take first 4 value become T and remaining 4 value become F. That the half of that. 4th value T and 4th value become F. Same for your provision Q. Take 2 value become T, 2 value become F. Because 4 rows, its half part is 2, that is 2, 2. Again in that same 4 rows, there are again 2. 2T and 2F. Again that 2's of half is 1, that is alternate TF, TF, alternate TF, again TF. Okay. So next column for negation R, take negation of that value. Negation of T become F, negation of F become T, negation of T become F, negation of F is T, negation of T is F, negation of F is again T, negation of T is F, negation of F is again T. Okay. Next column for P or Q. Okay. That means in the first and second column we will take OR. That means rejection. In that rejection, if both values are F, then its result value become F. So there is both F, then its result value become F. If both values are F, then its result value become F. In the remaining cases, all its value become T. So this all its value become T. Right. So what is the last one? That is P or Q. Again OR with negation R. That means this 4th column and 3rd column we will take 5th column or 5th column and 4th column we will take OR between that one, right? So in that OR, that is rejection. If both values are F, right? If both values are F, then the value become F. So here is both F, the result value become F. In the remaining cases, its value become T, right? So then in the remaining cases, its value become T, right? So from your last column, is it contain all T? No. Is it contain all value are F? No. Therefore it is not tautology, it is not contradiction. So given statement is natural tautology, not contradiction. That means this given statement is a contingency, right? That means it contains two value are T and F. Both values are accurate. So this second provision is contingency statement, right? So we have to make the last third provision. You have to make the truth table for your last third provision, that is negation of P or negation Q. Okay. Third one, we have to consider the truth table for the third statement, that is negation of P or negation Q, bracket complete, and take its negation. That means there are two propositions P and Q. So 2 raised to 2, that means 4 rows, right? So make the table, truth table. First column for position P, second column for your position Q, third column you have to make the for position of negation Q, right? Next fourth column you have to make P or negation Q, right? P or negation Q is your fourth column. What is your last column? Take the negation of whole bracket. That means negation of whole bracket means P or negation Q, right? This is your column truth table containing the 5 column, right? And the 4 rows. Okay. This is your truth table containing the 5 columns and 4 rows. Okay. Okay. So in the your truth table, for position P, take first 2 values become T, remaining 2 values become F. For position Q, take the alternate value that is T F, again T F. Next, third column for your position Q, take the negation of T, negation of T become F, negation of F become T, negation of T become F, negation of F become T. What is next column? That is P or negation Q. That is first and third column between or means the injection. In that injection, if both values are F, the result value become F. If both values are F, the result value become F. In the remaining cases, the result value become T. For your last column, take the negation of that the fourth column. So what is negation of T? Negation of T become F, negation of T become F, negation of F become T, negation of T become F. Okay. This is your last column. So your last column containing the both values are T and F. So therefore this third proposition is a contingency. Okay. So this is third example, 3 examples. You have to make the truth table. So next question. From the next example, determine which of the following statement is a tautology. And the next question, determine which is a tautology. Next question, determine which of the following proposition under the statement is tautology. Or contradiction. Okay. Determine which of the following proposition is a tautology or contradiction. The first one, P implies Q and P. P implies Q and P. Again implies P. Okay. Your first proposition become P implies Q and P. Again implies P. And second proposition is P and Q. Again and with P or Q. Okay. What is the second one? P and Q. Again and with P or Q. Okay. This is your third one. Okay. Now we are going to make the truth table for the both proposition and check whether it is a tautology or contradiction. And this symbol for your implication, or we can write as as also. We can both way. This is symbol for amplification. You can row this single line or double line. Okay, arrow will contain double line or single line. This is your conditional statement, that means your implication statement. Okay. So what is your first proposition? This is P implies Q. Again and with P implies P. Okay. This is your first proposition. Okay. P implies Q. Here is Q also. Okay. So first write down solution. Make the correction. There is Q. That means this is P implies Q and with Q implies P. We are going to make the truth table. So in that your proposition there are two propositions P and Q. So truth table contains 2 raised to 2. That means 4 rows. Okay. So make the table. First column containing the for proposition P. Second column for your proposition Q. Next column for P implies Q, right? And next column for Q implies P. That is P implies Q. Next column for Q implies P. Last column for between that two implication take the conjunction, that is and value. That is P implies Q and with Q implies P. Okay. This is truth table containing the 5 columns and 4 rows. Okay. So this is your truth table containing the 4 rows and 5 columns. Okay. For the first proposition. So for the first proposition, that is column P, containing first 2 values become T and remaining 2 values become F. Okay. For proposition Q, that is second column, take the alternate value, that is TF, again TF. Okay. Next column for P implies Q. Okay. That is conditional statement. Conditional statement shows that if first value is P and second value is F. First value is P, second value is F, then result value of TF become F. Result value of TF become F. And in the remaining cases, its value become T. In the remaining cases, its value become T. Next one, fourth column containing Q implies P. That is Q implies P. Second implies first one. Same the implication said that if first value T, second value F. First value T, second value F. First value T, second value is F. TF. TF implies the value F. TF implies value F. In the remaining cases, its value become T. What is the last fifth column containing? Take the AND between that two columns. AND is conjunction. Condition so that if both values are T, the result value become T. Both values are T, result value T for conjunction. In the remaining cases, both values are T, result value T. In the remaining cases, its value become F. Okay. So from your last column, show that it contains both T and F value. Therefore, it is neither tautology nor contradiction. Therefore, given statement is a contingency, right? And also result. From last column of above truth table, from the last column of above truth table, from the last column of the above truth table gives both truth values. From the last column of the above truth table use both truth values. That is T and F. Therefore, given proposition is neither tautology nor contradiction. Given proposition is neither tautology nor neither tautology nor contradiction. Right? Neither tautology nor contradiction. This is your result. Okay? This is neither tautology nor contradiction. That means given statement is a contingency. Okay? This is for your first provision. Next, we have truth table for the second provision. Okay? And this one second for truth table for second provision. In that second provision, there are in the second provision there are two provisions, that is P and Q. That means truth table containing 4 rows. Right? So make the truth table. First column for your provision P, second column for your provision Q, third column for P and Q, next fourth column for P or Q, and last column for between that two column take the AND, that is P and Q, take AND between P or Q. Right? This is your last column. So truth table containing the 4 rows and 5 columns. Okay? Okay. So for that truth table, first column containing for provision P. In that first column, we have to take first two value is T, right? And the remaining two value become F. For the second column, provision Q, take the alternate value, that is TF, TF. Okay. For the third column, that is P and Q. In the conjunction statement, if both values are T, the result value become T. If both values are T, the result value become T. In the remaining cases, its value become F. In the remaining cases, its value become F. For the or rejection statement, if both values are F, the result value become F. Both values are F, the result value are F. In the remaining cases, its value become T. Right? Now next column, we will take AND between that third and fourth column. AND between third and fourth column. In the conjunction statement, and if both values are T, result value become T. Both values are T, result value become T. So both value T, result value become T. In the remaining cases, its value become F. In the remaining cases, its value become F. From the truth table, from the truth table of the last column containing the both truth value T and F. So given statement is neither tautology nor contradiction. So it will become a contingency statement, right? So same result from the same. This is whole for. So this result also whole for. From the last column of the above truth table gives both truth values P and F. So given provision is neither tautology nor contradiction for the both provision. Okay. So I hope all the examples of the today's lecture we have understood. So remaining part we are studying in the next lecture. Thank you.